So for the first example, we have a fairly straightforward question. The fourth term of a geometric series is 1.08, and the seventh term is 0.23328. It's not the nicest number, but get a calculator, so it'll be fine. And part A says show that this series is convergent. So to solve part A, the first thing we need to remember is that it's convergent if the ratio is less than 1, the size of the ratio is less than 1. So this is our key. If we can show this, then we've done part A. So if the fourth term is 1.08, then that means that 1.08 is equal to A multiplied by R cubed, because remember this power is 1 lower than the term because the first one in the sequence has a power of 0. And then we also have that 0.23328 is equal to A R to the power of 6 because it's the seventh term. And the simplest thing to do now is to divide the two to eliminate the A from both terms. So if I divide them, then I get R cubed equals 0.23328 over 1.08. So 0.23328 divided by 1.08 is going to give us this value, 27 over 125, and that means that R is equal to the cube root of that, which is 3/5, or if you prefer 0.6. Okay, and since 0.6 is less than 1, so 0.6 is less than 1, so the series converges. And we need to make that statement just to make sure we're really clear and we know what's going on. And then part B just asks for the sum to infinity. And the sum to infinity is A over 1 minus R from the formula book. And we now know R is 0.6, but we don't know A yet. So what we need to do is we need to go back to our original. We know that 1.08 equals AR cubed. We know what R is. So here is R cubed from before. So what I want to do is I want to do 1.08 divided by R cubed. So A equals 1.08 over R cubed, which equals 5. So now I know that A is 5 and that R is 3/5 or 0.6. My sum to infinity is 5 divided by 1 minus 0.6, which is 5 divided by 0.4. Our sum to infinity is 12.5. And it's a fairly straightforward thing to do. Doesn't take loads of effort. And what we should see when we're doing a question like this, just as a kind of general pointer, is that the earlier terms should be larger than the later terms, because that indicates our values are getting smaller, and if they're getting smaller, a geometric series is going to converge. So it's all reasonably straightforward. The second example, geometric series with the first term A and the common ratio R. We've got S4 is 15 and S infinity is 16. Okay, so this time we don't have any specific terms in the sequence, we only have series information, and we know that Sn is A times 1 minus R to the n over 1 minus R, and we know that S infinity is A over 1 minus R. And it says find the possible values of R, and we've got a couple of different bits of information here. So we know first term A, common ratio R, and S4 is 15, S infinity is 16. So what I know is that S4 is 15, and that equals A minus AR to the 4 over 1 minus R. And I also know that S infinity is 16, So 16 equals a over 1 minus r. Actually, I'm going to keep this one in the bracketed form. And from here, I want to find some way of finding values of r, which means I probably want to eliminate a from these two equations. So if I write these two in terms of a, that'll be a fairly straightforward thing to do. So 15 multiplied by 1 minus r divided by 1 minus r to the n is going to be equal to a. And for this one, a is equal to 16 multiplied by 1 minus r. Okay, so we've got simultaneous equations. We can equate the a's and solve this from here. We've got a common factor of 1 minus r in both of these things. So I've got 15 over 1 minus r to the n, r to the 4 rather, because that was our power, equals 16. A little shifting around is going to give us that 15 over 16 equals 1 minus r to the power 4. And another little bit of shifting around is going to be r to the power 4 is going to be equal to 1 minus 15 over 16, which is 1/16. So r is equal to, and I want the fourth root of 1 over 16, which hopefully you'll spot straight away is a half. But there's a little clue in the question that that's not the complete answer. You find the possible values, plural, of r, because whilst one of the solutions is a half, we actually get a plus or a minus a half, because negative a half to the power 4 is also going to be 1/16 positive. So we've got two different answers here. R is either plus a half or minus a half. Two different answers. And then for scroll back up, part B, given that all the terms in the series are positive, find the value of a. So the fact that all terms are positive means we can immediately eliminate one of our two values for r. It cannot be the negative one, because if the ratio is negative, the signs flip between positive and negative every time. So now I know what r is, and therefore I can find a. So if we go back down to the bottom, for part B, r is definitely now positive 1/2. And it's much easier to use the sum to infinity. 16 equals a over 1 minus r for this. R is a half, so 16 equals a over 1/2. If I sort that out, that means that a has to be multiplied by half, 8. The first term in the sequence must be 8, and we're finished. Again, there's nothing massively complex here. It's really just plugging the values into the formula and then setting up solving equations, a bit of algebraic manipulation. There's nothing super hard here, so I think you should be able to tackle all of this now independently with a little bit of practice. I've set you up 2 sets of questions. The first is the much more straightforward question 1 to 5 from the textbook. I don't mind whether or not you do all of these, but I do think you should all have a go at a handful of these just to make sure you've got the basics down using the formula for this infinite series and finding the common ratios when you've got a couple of different things. And then the second chunk is 8, 9 and 10, some exam style questions. You can see how many marks they're worth, so you have a good sense of how long these should be taking you to do. And I do think you should all try and work through all of those 3 more difficult exam questions. All of those questions are in the email I sent you, so you don't need to access these video clips again. You can just check the information in the email and get them all done. If you have any problems with any of that work, please do email me. I am available on email and I will be checking them and responding during the course of the day.